In this video, I'll go over the GUI for PA4 for CS4760 Spring 2015. So the first thing you should do is grab the solution executable from the web page and unpack it and stick it into your skeleton folder. So here it is. So fire it up. So the first thing you should do is open an image. It's a TGA image. I'm using this cube. So one piece of functionality that this GUI has is computing the vanishing points. So in order to do that, you have to draw lines in X, Y, and Z directions. You typically want the Z direction to be pointing up. That's wrong. Try that again. Man, the Z lines. Okay, so then you can go to Tools, Compute VPs. If you look in the terminal, you'll see the vanishing points. And these vanishing points are in image coordinates, 2D image coordinates. So the next piece of functionality that this GUI has is computing the reference homography, which is between like any view of the image and the ground plane. So to do that, you'll go to Tools and use Compute Homography. So Compute Homography, it takes points on the ground plane. You can either give it 4 or more points on the ground plane, and if you give it less than 4 points on the ground plane, if you give it 2 or 3 points on the ground plane, it'll take the X and Y vanishing points as 2 other points on the ground plane. So we have to draw a point. So go to Edit, Point, and draw a point here. So this GUI uses, or the program uses a point stack, which I'll get to soon. So hit enter over point to specify its 3D scene coordinates. So I'll do these 4 points here. And 1 point needs to be used as a reference height. Okay, so back to the point stack. So to put a point on the point stack, you put your mouse over it and hit the space bar. And do that for a couple of points. Even points connect the lines. And to take points off the stack, just move the mouse away from any points and hit the space bar. Okay, so now in order to call compute homography, you need to put a set of ground points on the stack. So I'm putting these 2 points on the stack, and the X and Y vanishing points will be chosen as the other points on the stack. And one thing to note is when you're computing homography and you only specify 4 points, 3 of them cannot be collinear. That'll be a problem, or even close to collinear. So now I'll go to Tools, Compute Homography, and here's the homography. So another feature that this GUI has is saving models. So a model is a text file that basically saves the state of the program. So it's handy if you're dealing with like complicated scenes for your artifact, or your GUI crashes or something like that. So you can save it like that, and you can close the program. Reload the image. and open the model. And there you go. Okay, so there's a couple more useful functions. So next is drawing polygons. So you can go to edit polygon and you can draw a polygon. So a polygon is just like a polygon. So you can use existing points as vertices of your polygon, and to do that you just hold the control button while you click. So I'll start up here. So there's the first corner. I'll hold control to click there. I'll click here, and then I'll close the polygon by pressing enter. You have to give it a name, and you have to actually click enter, otherwise it won't work. And then you can use the same z-plane and same xy functions to compute the scene coordinates of the vertices of a polygon. So, and the way to do that is you need to put the points on the stack. So you put your known point on the stack first, and then your unknown point. So in this case, these 2 points are on the same z-plane, so I'll call same z-plane. And if you notice, this x-coordinate is around 2, which is kind of what we would expect. You can put this next point on the stack, same xy. And then you have a polygon. So let me reopen the model file to go back to what we had before. So there's 2 more pretty useful functions. They're XZ rectangle, sweep rectangle. So first we'll draw XZ rectangle. Just put your mouse on like an anchor point, and you can draw the rectangle and name it. And then you can again use same XY and same Z plane to compute things. So I have 1 polygon. Then sweep rectangle, what it does is you just pick another anchor point. You can sweep outward. So I'll place it here. This computes the rest of the vertices for you. So if we look back at this vertex, go back to point. This vertex, it's a little bit off, but it's probably because I was being sloppy. Alright, so now we have this. So now we can save our VRML models after we have all the polygons we want. So you have to be careful here, because if you press enter without entering a file name, you'll segfault, and that's not good. So cube.wrl. So I'll save that. I guess I'll save the model as well. Close this up. Then I'll fire up View 3D Scene, which is the VRML viewer that we recommended. Open up the file. And so right now, you have the shape, but the textures aren't working because we haven't converted them to GIFs yet. So I'll do that. So for some reason, the GUI saves these TGA files inside the skeleton directory. So I'm going to convert them to GIFs and move them to my desktop so they're in the same directory as the WRL file. I think I've run these commands in the past. Now, if we open the real file, we have our cube. And again, all of these irregularities are probably due to me not being careful while I was putting together the 3D model. It might also just be because of the shape of the cube. But that's it. So your final product should be something like this. And that's about it.